Okay, so you want to be on our software team. That's great. Let's go over our code. I'm not going to show you how to set up your Java environment. So there's a guide already. If you Google FRC Java, you'll find this guide and you can walk through how to install Visual Studio Code and get Java installed and set up and WPI lib set up. So it's about installing this, and then over in Visual Studio Code, going to extensions and making sure that you have the Java extension pack and the WPI lib extension, and all of this should be set up so you should be able to create a new Java project or WPI lib, create a new project here. Those things should be working for you before you're able to get started working on the code here. Code this year is in the Titan repo. We're going to need to restart all this and get this going again. Right now, this is just our practice. So, but the repo will have the same link, so we can copy that now, and we'll go to right this one, Visual Studio Code. And now I want to git clone this repo, paste that in here. Where am I going to store it? I'll go into projects, and that's fine, and I'll make a new folder for Titan in that place. There it goes, and let's open it. Here we are. We've got the code. Alright, and it's recognized it as a WPI project. It's booting up a bunch of Java stuff, so it can tell me if I'm making any mistakes. Got a terminal failed right away. That's not great, but I'm not. See, Java 11 required, but I'm rocking Java 13, so I might have some problems there. But we'll come back and deal with that. Personally, I always like to follow the thread. So every Java app always starts from the main method, and here we use some fancy programming to just basically start a new robot. So the main quickly hands things off. The focus of the app comes back down to robot. So robot is going to have all of our primary logic. Mostly ignore main, because all the main does is hand things over to robot. Now robot, we'll come back to this and dive in deeper with what robot has. But let's first talk about these other two files, OI and robot map. Robot map is easy. It just, we're going to refer to like, what is my A button on my controller? What is my Y button? It's button number 4. Rather than try to remember button number 4, we're going to have these constants. That's why they're all written in caps, because they're just final and public static final int. So we could note them final here. It's the same basic thing. It just means that they won't change. And that's why we're writing them in all caps. So we're just linking, saying, hey, if I refer to that, it's that. And so as we add in new ports for our motors, for our digital input-output signals, we'll need to update robot map. And that way, if we plug things into different ports, we don't need to go through all of the lines of our code and find where that was and update it. We'll just need to update it in one port, in one place, because left one is linked to this number in this file. So these are called magic numbers. Main kicks over to robot. Robot sometimes refers to our robot map, which is just really a phone directory of all of our ports and where stuff is plugged into. OI is a little bit different. This is the operator input. I think that's what it's called, right? Operator input. Anyway, it just it sets up all of the button triggers. So while the Y button is held, run this command. So we create these buttons here, and see, this is silly. This is bad. We're saying, okay, X button, and then we use the fixed port on where the X button is instead of using the robot map here for X button. So we should be using this right here. We should have robot map imported up on the top, and then instead of using all of these fixed magic numbers, if we use a different controller, we'd have to remap all of this stuff in this file, as well as over here in this file. So OI should refer to the robot map on these port numbers, and we're not doing that, so that's not great. We need to fix that. But anyway, so those are your these are your main files inside of the Java FRC folder of our source. So source is where all the programming is kept, and then everything is kept inside main, and then inside Java FRC robot, this is where everything lives. And these are the files. Main kicks everything off. It creates a robot, which refers to our button maps and our operator input, which just sets up buttons and binds them to particular commands. Commands are a really big deal because we follow the command pattern. A lot of stuff you can read about in command-based programming and what this command pattern means. I'll give you a quick rundown of it. It basically means we put most of our code into these two folders, commands and subsystems. So a subsystem like our gripper, our drive, these are subsystems. This is an example one we can just copy from when using it. We don't actually mess around with the example. But we have drive and gripper. And so we have all of our motors and other things are defined in our drive. So all of the parts that make up a drive subsystem are there. Same thing with the gripper. The motors that do that, and any other sensors that we might add. This is a pretty hollowed out file right now. But will all be kept inside this subsystem. Big advantages to that. So if we make a command to drive to the wall using our distance sensors, for example, then it will take over the drive subsystem, and that will interrupt any other command currently using that drive system. So we have a system built in that will avoid two things colliding, two commands, contradictory commands colliding. Because if let's just look at an example command. An example command has an interrupted function built in. What happens if I'm interrupted? What do I do? All right, I cut power to certain things. I stop doing that. And then the other command will take over and run from there. So this command pattern has these requirements that every command needs to have. What happens when this command is first created? Note that I require this subsystem. When I'm first running this is like when the robot starts and I bind everything up. When I first get this command actually executing, what do? Maybe I want a counter to count a number of seconds or whatever. I can get that counter going. This is repeatedly called while I'm executing, and executing will also trigger, am I done? Am I done? Am I done? This will be a never-ending command because it'll always say, no, I'm not done. No, I'm not done. Something like that works really well if in my OI file I have it while held. So while I'm holding it, keep on doing this thing, and the command is never finished because as long as it's being held, I want you to keep on, moving or spinning, whatever the command is telling in execute. So just keep on going because I don't want the computer to automatically tell me when I'm done. I'll let you know when I'm done when I let go of the Y button, for example. Okay. And it happens when this command is automatically, when is finished, returns true, and saying, yes, I'm done, end will automatically be called. To summarize, we are following the command pattern, which means we have this command file and a folder of commands and a subsystem folder of subsystems. And so we will keep our code organized like so. Commands will require a subsystem, will automatically, because of this pattern, cause the interruption of any other command. Once a command starts that requires a system that's already in use, we'll cut out of that. Commands can be default. So what I mean by that is this is my drive subsystem. So it's what drives the robot around. So it's the basic of drivetrain, and it has all these motors combined together. and it sets a default default command. So after it just wires up the motors and it says, "Hey, I'm a mechanum drive." That means I'm cool. I can drive side to side. Then I have an initial default command saying, "All right, when I'm not doing anything, use this drive command." So what is drive command is? This is just simple. Look at my look at my controllers. I have some dead space, so ignore any really small movements. But other than those really small movements, constantly look 30 times a second, execute, compare what my joystick's left, right, and forward and back motion is, and set that to my drive. So as my controller, as I move the stick, then update my drive command, my motor power, proportional to the value of these sticks. So that's how I can drive left and right and forward and backward, is simply because the drive command is running by default and it's 30 times a second or so, checking to see what my controller stick is, and it's saying, "Hey, robot," let's go through and explain what all this stuff is. But it essentially says the subsystem drive has a default command to watch my joystick and power the motors proportionally to the joystick that it says. And because I have it manually built inside this execute, it's also, I can build in extra helpers here, like saying ignore anything below my dead value. So that way, manual dead zone. So you have to move the joystick over 15% before it starts registering that you want it to move. The drive command is never finished. It's always, when the robot's on, it's ready and willing to listen to your joystick commands. But if it's ended for some reason or interrupted, then it sets the power to all of the directions that Drive Cartesian has. This is just something that was given to us from FRC, and it will just set that to 0. So if you interrupt it, it cuts power, and then allows you to move using a different command. But because the default is drive command, once any other command is done, it'll go back to its default. And that's how, if over in OI, I made some sort of button that takes over and drives the, like maybe we had this last year, we pressed a single button that spins the robot around 180 degrees. And so it would execute its command. We don't have one here to show you, but once that command ended, because it said it finished, I turned 180 degrees, and so end cuts the power back, and then the drive system says, "Okay, I'm done with that command. So I guess I should go back to drive command," and then after executing that 180, it's back ready to listen to your joystick and drive proportionally. Proven really helpful to us. Before, we'd have files kind of all over the place. You don't have to use this command and subsystem pattern. We've found that this brings a lot of order and avoids some errors. Before, essentially everything just was crammed inside robot. Sometimes we'd have other files, but really everything was all centered around robot.java. And so our goal is to have less in this file and more inside specific command and subsystems. And that's particularly helpful. So make sure you understand, ask me any questions about commands and subsystems, try to get the idea of that down, and then now let's take a long look at what's in our robot file.